Hello, my dear lovely students. How are you? I hope you are quite well and your study is going very fine. Today, we are going to start the lecture number 20, Aldol condensations of ketone. So, let's start, students. Once you understand, please like, share, and subscribe the channel. Students, see that we write here the aldol condensation of ketone. The one example we'll take here, the simplest ketone, that is the CH3, C double bond O, CH3. Another compound we are taking here, the CH3, C double bond O, CH3. Student, we will use here the barium hydroxide. Why? Because sodium hydroxide will not undergo self-condensation, self-aldol with the ketone. So here we will take the base, and through base we generate the nucleophile generate the nucleophile from one ketone which contains the alpha hydrogens. So here that CH2H C double bond OCH3 OH minus will attack here, and that will generate the CH2 negative C double bond OCH3. Correct? Now this nucleophile strength will attack on this electrophile, and what happened? See that CH3 C double bond O CH3. We have the CH2 negative C double bond O CH3 that will attack here. It will move into that sides, and then that CH3 CO negative CH3, and then CH2 C double bond O CH3. And through the water will take here, that will attack here. Already we know that hydrolysis, and then we get that CH3 COH CH3. Here is that CH2 C double bond O CH3. Okay, so that the aldol is formed. What the form? This is the strength. It is not aldol, it is called ketol. So in aldol condensation of ketone, in aldol condensation we saying the aldol, but in ketones condensation we saying the ketol. Okay, so this compound name is 1 2 3 4 5. What we can say, students, here? 4 hydroxy 4 hydroxy 4 methyl pentane 2 on. There is another name is what we can say, diacetone alcohol. Diacetone alcohol. What the name is? This is called diacetone alcohol. So we have the compound which form is called diacetone alcohol is formed, right? Students, see that the diacetone alcohol, what will do? Student, diacetone alcohols, see that the compound, the dehydration will happen, that the dehydrations happen, and how it will happen dehydration, students. Already I have a doubt in the previous video lecture. Despite being I also a teacher, you can see that the CH3, see, by simply in the shortcut we can say that the heat we supply, water will loss, and then the CH3 CH3, and then what will happen? Double bond CH C double bond O CH3 will form. So in simplest way you can write it, but logically you can go with that. Here is the OH, here is the CH, and one H C double bond O CH3, the base which will attack on the acidic hydrogens, and then the CH3 COH CH3 CH negative C double bond O CH3 will form, and then it will move here, and then what will happen? There is CH3 C OH CH3 CH double bond C O negative CH3. Now it will come here, and then OH will leave the position. So this will group C ketonic group, in hence the OH act as a nucleophile, act as a better living group. Sorry, OH is as you know, OH is a good nucleophile, but due to this compound it will act as a better living group. So what will happen? That will form the CH3 CH3 and double bond CH C double bond OCH3. The name of this compound is mesityle oxide. What the name? There is name is mesityle oxide. Now mesityle oxide, there is alpha hydrogens, and the acetyl oxide here is, if you will take again acetone, then CH3, C double bond OCH3. Then acetyl oxide again will react in the presence of barium hydroxide, and what will happen? I write directly here that this is the acetone will act as a generate as a nucleophile, and that will attack here. The hydrogen will come here. So CH3 CH3 double bond CH, okay, COH CH3 CH2 C double bond OCH3 will form, because one hydrogen will come here and that rest group will attack here, and then the dehydration will happen. So what happens? CH3 CH3 double bond CH, CH3 double bond CH, C double bond OCH. This is called 4-on. 4-on. Okay. Students, you can prepare the 4-on directly in the acidic medium. So actually, we in the last lecture in the aldol condensation, we have done the acidic and basic both way aldol reactions. So if you take the 3 moles of CH3 C double bond OCH3 in the presence of dry HCl, what will happen? That 4-on you will get that 4-on. Okay. So directly you can get the 4-on. Still see that what they happen in the aldehyde and ketone, the aldol C strengths. In the last video lecture, we have done the mechanism, and through mechanisms, I taught you that when you take the aldehyde, there the RDS is the enol. So when the enol, and that will form the product. Okay, product is the condensation product. So this step is the reversible step, right? So aldehyde, the aldehyde enol is reversible. But students, so what the interesting logic is, this enol always tends to move towards the product side. Means equilibrium will always favor the product in the aldehydes, right? Means once the enol is formed, that enol will move into the product side. Means formation of the product. Okay. But when you take the ketone here, students, that ketone will be reversible and form the ketol, and that ketol form the product. But at the same time, that also will move into the backward reactions. The backside, that will ketone will move into the backside, that is called retroaldol. So retroaldol means opposite of aldol, precursor of aldol, right? That is called retroaldol. So retroaldol will form. That is a through the, especially when the ketone you will take that, or complex compound you will take that, because why ketone will move into the retroaldol? Because ketone is complex compounds. Okay, so complex compound will move into the retroaldol. But if the compound is not a complex, they will move into the forward directions. Ketone will move forward as well backward both, right? Even though backward you will get that good amount of product, means major product you will get that through the backward reactions. See, understand that retroaldol, one example here, which will then you will understand what I'm telling you, that how to obtain through the retroaldol product. See here, students, see that the, suppose we have a one reactions here, and that reaction say is here I write here. Okay, that see here, we have the CH3 C double bond OCH3, that is the retroaldol concept. The retroaldol concept will be clear here through one more example. CH3 C double bond OCH3. Okay, so here is that OH will be there. Okay, so through OH, what will happen? It will generate the nucleophile CH2 negative C double bond OCH3, and then it will attack here, and then you will get that CH3 COH CH3 CH2 double bond COC. At the same time, when that compound which generate the nucleophile do the hydrolysis, and then you will get that CH3 C double bond OCH3 along with that CH3 C double bond OCH3. So at the same time, you will get that backward reaction, which is called retroaldol, and as well as you will get that this compound diacetone alcohol. Okay, because as you know, diacetone alcohol, if undergo into the condensation, that will form the acetyl oxide. Already we have done that. Okay, so backward direction, which is the retroaldol. Already you have taken. Once the OH minus you have taken, that the nucleophile will generate, and this and then do that hydrolysis, you will get that same product in the backward direction product. You will get that. Okay. Now that students move into the intramolecular, cross aldol condensations. Okay. The cross aldol. Where I write here cross aldol condensations. What happens in cross aldol? See, cross aldol happen either if you have a two different aldehyde group. If you have two different aldehydes, if you have, or second you have two different ketones you have, or if you have one aldehydes and one ketones you have. What happen if you have one aldehyde or one ketones you have, like that? Two different compound you have. There is NCERT question number 8.9 I think, or 12.9 in the old book and 8.9 in new book in the aldehyde chapter exercise question. You can see that there is given that the propanol, if you have the propanol CH2 C double propanol and you have butanol that the CH3 CH2 C double bond or COH aldehyde. This is A, it is a B. So the question is, there are how many product will form? There is a 4 product will form strength. If you have both the compound A and B, if both contains alpha hydrogens, then the 4 product will form. And you can see here, A plus A, there will be self aldol. B plus B, you will also get the self aldol. A plus B and B plus A. See, in every cases, A or B, any one compound, if there is alpha hydrogens, that will act as a nucleophile, other will act as electrophile. Similarly, if here is act as a nucleophile, it will act as electrophile. If it here act nucleophile, it will act as electrophile. In all the process strengths, the product will be different. So through this way, you will get the 4 product, right? But you must have the both the compound alpha hydrogens. Now the question is, which will be the more stable? Correct? That is in theoretically you can form the 4 product. That is theoretically. But actually, students, see what happens. See, if you have a CH3 C double bond OH and CH3 CH2 C double bond OH, what will happen? If you have taken the OH negative, student, OH will attack on this ethanol. Why? Because ethanol is more acidic than the propanol. So OH will attack on the ethanol and generate the nucleophile. So what happens? That will generate CH2 negative C double bond OH, and your second compound CH3 CH2 C double bond OH, it will act as a nucleophile. It will act as electrophile. So it will attack here on the propanol. And what is going to be happen? CH3 CH2 C O negative H and CH2 C double bond OH, and here is the water you have taken. So what is going to be happen? CH3 CH2 COH H CH2 C double bond OH CH2. Once the condensation product is formed, then reaction will not be reversible because condensation is highly conjugated system, a stable product. Correct now. So therefore that aldol is reversible. Here is reversible process, but if the process is going to happen, if heat is supplied or if simply dehydration is OH minus you have taken, the water will lose right now. So now those students who know the mechanism, that they can give me the response perfectly, where the where the double bond will come, at these positions or these positions. Where do you think that the students here that even CV mechanism is applied? So Hoffman elimination is a major product. So what happens? CH3 CH2 CH double bond CH C double bond O CH3 will form. Correct now? So what do you think, students, here? What I'm telling you, see here, students, one thing, see that, is keep in mind, if you have taken the base, what you have taken the base, if you have taken the base, so in the base, lower aldehydes gives gives nucleophile. What? Lower aldehyde gives the nucleophile. But keep in mind, when you have the acid in presence of acid, what will happen? Higher aldehydes, higher aldehyde gives nucleophile. Why? See that same compound, same example we are taking here, and then you can check that CH3 C double bond OH. Other compound we have taken here CH3 CH2 C double bond OH. Okay, we have taken the acid. Now tell me in the acid that which will act as a nucleophile, which is more basic. So it is more basic. So therefore, what will happen? That CH3 CH negative C double bond OH will form. Right now. Now it will attack on this second molecules which will act as a electrophile, and then CH3 COH directly I have written here. So I hope you understood that CH3 C double bond OH will form. Correct now? So that things will happen, students. Now your question is, sir, when the aldehyde and ketone we have taken, then which compound act as a nucleophile? Student, case third is when you have taken aldehydes and aldehyde condensed with ketones. Okay, then ketones generate nucleophile. What generate ketones? Then ketone generate nucleophile, and aldehydes uh, is the acceptor. What? Student, aldehyde is the acceptor. Correct. So in that case, we have suppose we have taken that CH3 C double bond OH, and here is that CH2H C double bond OCH3 and OH minus. So OH minus will attack here. Here is the CH2 negative C double bond OCH3, and here is the CH3 C double bond OH. So it will attack here, and then compound will form CH3CH OH. So these things will happen. But one thing I am telling you, when the formaldehyde you have taken, that the one questions came in the IIT, and the what question says that in IIT JEE, that the question is 2012. In 2012, what question was there? You have a CH3CHO and 4 moles of HCHO. Okay, and you have taken that aqueous NaOH. So what the product is that? Here is that OH, 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 and OH. So that things, the question is that how many aldol will involve? How many aldol involve? Number 1, 2, there is of 3, and there is a 4. What? How many aldol will involve, students? Can you tell me? Students, how many aldol will involve? Tell me. See here, students, that the 3 aldol will involve. What? See that for HCHO is very small size, which will attack on this alpha hydrogen of the acetaldehyde till that when all the hydrogen will not be removed from the acetaldehydes. So it means 3 times your acetaldehyde will act as a nucleophile, and 3 times it will act as a nucleophile means 3 times it will act as a, then 3 aldol will get that. See how? Understand here. First we generate that this compound here, the CH2H and C double bond OH. So first we have taken the base. Through base we have generated here nucleophile CH2 negative C double bond OH. Right. Now what happened? Now first formaldehyde you have taken. Now it will attack here, and you will get that CH O negative CH2 C double bond OH. Now that protonation here, and H C OH H CH2 C double bond OH, you will get that. Okay. So subsequently you have the 2 times 2 hydrogen still there. So it will 2 times will form the acidic hydrogen. Okay. First, it will form the acidic hydrogen here, CH2, OH, CH, okay, H, right? So, and second, you will get that, through the, first we take the water and then CH2. I thought I will move directly. CH, CH2OH, C double bond OH. Again, you will take that OH, so it will attack here and you will get that CH2OH all to C, CH2OH, C double bond OH. So you will get that here is 3 times CH2OH all 3 C, C double bond OH, right? So this compound name is what? Trihydroxy methyl acetaldehydes. Okay. Now, okay. So there is a 3-hydroxy means 3 times you will get that aldol. 3 aldol will involve. Now from here no aldol because no alpha hydrogens, and you have taken that. What compound you have taken? 4 moles. So 3 moles you have adjusted, you have taken. For me 1 moles is left. So students, neither this compound contains alpha hydrogen nor formaldehyde contains alpha hydrogen. So from here there is a cross kinase reaction will start. So CH2OH all 3 C double bond OH, you have taken that HC double bond OH. Okay. So through cross kinase you will understand through the mechanism. So what happens, students? There is what things will happen. A small more reactive substances will be oxidized. So this will be oxidized and which will form the HCOO Na if you have taken the NaOH conc NaOH, right? And this part will form the CH2OH all 4 C. There is a name of this compound is tetrahydroxy methyl methane. Okay. So tetrahydroxy, there is a 4 methyl methane, you will get that. Okay. So that this product you will get. Okay. So that is the this is the product here. I hope you understood this whole reactions. Students, one thing keep in mind here. You have in the NCERT book. Okay. The thing says if you have taken the ketone CH3 C double bond O CH3, one react compound is ketone, other compound is anything, maybe that aliphatic or aromatic, either aliphatic or if you have the aromatic, anything you have substances, and through that if you have taken the NaOH, that the 100 degrees Celsius you have taken, then you will get the same product. Suppose the CH3 C double bond O CH3, and second product I have taken the benzaldehyde. Okay, you will benzaldehyde we have taken here. Okay, so here is O and H we have taken. So through this process, this what the product you will get that product you will get that students benzene C. Okay, because it will act as a nucleophile. So here is the OH, right? Here is the H and the CH2 C double bond OCH3 were taken, and then the product is from the CH double bond CH. Mechanism is the whole logic extends. Actually, when you take the ketone along with any substance, this reaction is name is called glycine Schmidt reaction. Students, claisen discovered this reaction and Schmidt developed this reaction. Why? Because especially sodium hydroxide, the ketones do not self-condensed with the sodium hydroxide. Now, claisen has done this job exactly through 100 sodium hydroxide and some temperature 373 Kelvin and supplied, then successfully got that the ketone condensed and the form this compounds. Okay. Students, I hope you understood. Once please you understand